Hi gang, so I'm going to try to see if I can make this work. So you were asked to find the general slope for this guy, and if you recall, this was a rational function. Rational functions occur when we have asymptotes 98% of the time. Rational functions will have asymptotes. So if you look at the function, you can actually see that we have an issue when x is equal to 1. Yeah, so we already know that our domain restriction is all real numbers where x cannot equal 1, because that's what's going to cause us trouble in the long run. Now, if you wanted to get a quick sketch of what this graph looks like, the nice thing is you already know that at x equals 1, we have an asymptote there, and I'm just going to tell you that you have a horizontal asymptote at y equals 0. So now, at this stage of the game, either the graph is going to be up here or down here or up here and down there, because the asymptotes break the graph down into quadrants, okay? So in order for us to determine who's who, what I like to do is I'll pick some values for x. So for example, if I put 0 in here, I'm going to have 1 over 1 minus 0, which is just 1. So at 0, we're up here at a positive 1. So in my mind, it's already telling me that the graph is going to be up in this quadrant 3, if you will. Now, to see what's happening to the right of 1, we can pick a number to the right of 1. Like, in other words, I just picked a number to the left of 1, which was 0. Anytime you can use 0, use 0, okay? So if I were to put, like, 2 in here, I would have 1 over 1 minus 2, and 1 minus 2 is negative, so that would be a negative a half. So it's almost telling me that I'm going to be in quadrant 3, and I'm going to be over here in quadrant 4. So, and again, when we graph this, our graphs are always trying to get to the asymptotes, and if we were to plug numbers in, we would actually see that it's trying to do something like this. So when you see asymptotes, our curves are always trying to reach the asymptotes, but they never do, okay? So this is just to get a nice picture of what it is that we're trying to find. And if you guys did this on Desmos, you would have recognized it, and again, you can easily figure out what it's doing. So now what we want to do is we want to find the general slope between those 2 points, so we have our f of x plus h minus f of x all over h. So in this case, we have to find out what f of x plus h is equal to. So I know that f of x is equal to this, so everywhere I see an x, I'm going to replace it with x plus h. So therefore, I have 1 over 1 minus parentheses x plus h minus 1 over 1 minus x, and that's all over h. Now, distribute that negative sign through. That negative sign means everybody inside is switching signs, which is why I always tell you guys, please keep your eyes out for the minus with that parentheses, because if you don't take care of that, nothing, you know, it's going to come back to haunt you in the long run. So when I rewrite that, I have 1 minus x minus h minus 1 over 1 minus x all over h. Now my goal now is to find a common denominator, and if you notice, the common denominator always seems to be the product of these two, which should make sense, because if this was like 9 and this was 10, the common denominator would be 90, which would be the product of these two. So I'm literally multiplying the top by that and the bottom, because I'm literally multiplying it by a form of 1. So this is 1 minus x minus h times 1 minus x over 1 minus x minus h times 1 minus x. Now, when we do that, this is technically over 1, and this is technically over 1, because my thing is, this is considered your numerator, these are your denominator. So when you distribute, and again, I'm going to grab that and go with my parentheses, I'm going to multiply this whole thing by the first term, and this whole thing by the second term. And when I do that, I will do that out for you guys, okay? That's going to be 1 minus x minus h times 1 minus x times 1 over 1 minus x minus h minus 1 minus x minus h times 1 minus x times 1 over 1 minus x. And that's going to be all over h times 1 minus x minus h times 1 minus x. So all I did was I did this times this, which is where I got this. And then when I did this, I literally distributed to there. So when I distribute, I get this. And when I distribute to here, I get this. Now, it might be wise to throw this in parentheses and that in parentheses so you can actually see that this factor here cancels out with that factor there. So when they do that, Don't you love my color coordinating here? I'm left with a 1 minus x in that term, and then minus. So this term here is going to cancel out with that term there, so we have this whole mess here. Now remember, carry that parentheses through again, because it's 1 minus x minus h, and that's going to be all over h times 1 minus x minus h times 1 minus x. Okay? So now when we distribute through, we're distributing the negative sign to all three of those terms. So now we have 1 minus x minus 1 plus x plus h, and that's all over h times 1 minus x minus h times 1 minus x. And if you notice up here, everybody cancels out except for that beautiful h. So that cancels out with that cancels out with that. So now all we have left is h upstairs and an h times 1 minus x minus h, there's a minus sign there, times 1 minus x there. And the beautiful thing is, if I have an h up here and an h down here, I can cancel, make that a 1, and make that a 1 also. So therefore, my general slope is going to be 1 over 1 minus x minus h times 1 minus x. So this right here is equal to our general slope for this function up here. So this is the general slope for f of x equals 1 over 1 minus x. So the nice thing is if I want to find the slope between any 2 points on this curve, okay, I'm going to go ahead and substitute it in here, and we'll do more of that on Tuesday in class. So this takes care of the first one, okay? And one thing I want to note too is if I find the slope between any 2 points up here, and I draw a secant line, any here or here, my slopes are always going to be positive. And if you look in here, my slopes are always going to be positive because this is positive upstairs, and then anything that I multiply out here is going to wind up coming out to be a positive number as well, which I will guarantee I will show you on Tuesday. That's number 1. We're going to go on to number 2.